Good afternoon. Hello. Thanks for coming along. My name's Robin. I work for a company called Confluence. And I want to spend the next 40 minutes talking to you about Apache Kafka, what it is, and what you can do with it that you may not actually realize. So, quick show of hands. Who was at my talk earlier? Awesome. Obviously, it wasn't too bad. Otherwise, you wouldn't have come back. Show of hands, who's using Kafka? Good stuff. So some of you will know about Kafka already, some of you may not. Last show of hands, I promise, and then I'll actually do something and tell you stuff. Who would class themselves a developer, like I write programs and services and microservices and stuff? And who would class themselves like a data engineer, developer type person? Databases, data warehousing, analytics, that stuff. It's not, you don't have to be embarrassed. Come on. That's my background as well. There's nothing wrong with this. It's an honorable profession. OK, so it says above the door, developer conference. So like tons of you developers. There's a bit of crossover. Some people analytics as well. So what I'd like to talk about today is pipelines and how we go about building them and how about we've always gone about building them and how we should maybe think about changing how we build them. And pipelines actually apply to all of us in the room. Pipelines, most people think of data pipelines, data engineering as being this thing that data science teams do and develop and kind of data engineers do, getting data from this source of information into a data warehouse, and whether we call it big data in Hadoop or data warehousing on relational source, it's kind of like it's all that kind of pipeline-y stuff. But microservice developers are also building pipelines. You're working with data coming from somewhere, you're doing something with that data, and you're doing something with it. You may be putting it somewhere else. So kind of broadly speaking, if you kind of like squint at a kind of quite a high level, it's all about data coming from somewhere, doing something with it, and putting it somewhere else. And all of these pipelines that we build always start off very, very small and precise and lovely. And how we build them makes a lot of sense at that point in time. We're going to get some data from here, and we're going to put it over there, and maybe change it a little bit on the way. And so it makes a lot of sense just to use this particular tool and that particular tool, because all we need to do is get data from here to there. But then as these things do, they tend to evolve a bit over time. And one pipeline becomes kind of like 10 pipelines. And these things are good, and they drive the business, and they stay in place, and they mature, and they grow. But these pipelines are never just isolated. There's always a case where, well, this data that you've got over here, we could do with using it over there. And so these pipelines start being, well, I'll copy it from here to here, as we're supposed to, and then I'll tack on this bit over there that's going to go from here over to there via this and stand on your head, and before you know it, there's always these kind of like skeletons that start emerging in our closets. It's like, I wasn't particularly proud of how I did that, but it got the job done. Would I have done it like that with hindsight? Probably not. But we do these things for a reason. We do these things because that's how we've always done them. We've always just evolved our thinking along, well, here's a database, it's kind of a quicker database than it used to be, and so we'll just keep on doing things how we used to. And it also used to be so much more simple. We had a small little toolbox. It was usually vendor branded, and you wanted a tool that did this, well, you went and picked out the appropriate red-colored tool that did that, or the appropriate blue-colored tool that did that. And it was simple. But then things changed. Things like open source came along. Things like the cloud came along. Things like Docker came along. And suddenly, you've got all this plethora of technologies at your fingertips. We have so many more places where we get data from. It's no longer a case that we're building a warehouse, so we get data from our single transactional system. Or there's our sales system, there is our inventory system, and that's where our data comes from. We've now got data coming from anyone in the company who's creating data, because everyone's using data, creating data. People are IT-minded. They have systems that they don't have IT building it. They've just gone and done it themselves because people can, and that's great. You have data coming from third parties. You have data coming from various different clouds. You have data coming from all these different sources. And so this mindset of, well, I build pipelines just by taking data from there because there's only like one or two sources, that kind of becomes invalid. Because of so many more different places from which we're trying to integrate data. And on the flip side, so many more different places that we're going to use that data. We're not collating data from this couple of sources into this one golden central data warehouse here. And that was never quite a good idea in the first place. We now have lots and lots of different teams wanting to use data. People understand the power of data to drive a business, and so they want that data that we're building in these pipelines. We want to centralize it and kind of conform our dimensions and come up with one version of truth and all that kind of good stuff. But that data that we're producing there for our standardized reporting is also used to drive the systems that other people are building in our organization. So now these pipelines from here to there become here to there, plus here to here to here, usually via some god-awful route of Excel and CSV files. Yeah? So there's more places in which we want to use the data. And then there's simply more data. Saying big data is kind of trite nowadays. It's like big data, blah, blah, blah. And Hadoop's kind of fallen into this kind of interesting position where it's not quite the panacea that it was going to be. But there is more data than we started building these things a few years ago. When we came up with these mental models of, well, this is how you kind of like build integration, there is simply more data generated by devices and mobile things and applications and logs and all of this data. We sometimes need to address how we deal with it in a different way. But we don't. We still build our systems based on an old way of thinking. We still think, I've got this data in this system here, I'll kind of run a batch process to extract it once a day, or I'll get fancy and run it once an hour or something like that, and then I'll go and land it into a bucket over there. And then I'll wait a bit, and then I'll run a batch process that will kind of take that data and do a bit more processing, and then it will write it over there and copy it over there. And we do things how we've always done them. We also have this mindset in our organizations. Like I asked at the beginning, who's the application developer, who's the data engineer, who's building applications, who's building analytics. And organizations do this thing with their teams because technology has driven us in that way. If you're building applications, you need something which is going to be fast to get your data in. You're going to need kind of OLTP type things. You're going to have your own technology stack. If you're building analytics, you're building data warehouses, you need stuff which is going to be fast to get the data out. You need kind of like OLAP style systems. So you're going to have your own technology stack. So these own technology stacks have their own kind of like domains and expertise, and people do this. But at the end of the day, it's the same data that we're working with. It's just we're doing slightly different things with it. Applications are kind of like driving processes based on what the users are doing. Analytics is kind of reporting on what happened, but it's the same piece of information that's actually driving both. But we somehow decide that it's a good idea to model these things as completely separate systems, or to implement these things as completely separate systems, because that's what we've been compelled to do in the past by technology choices. But it's the same data. It's the same data that's going to be useful amongst a particular business division. It's the same data that's going to be useful across an entire organization. It's just how we work with it differs. And at the heart of it, that same data is built on events. So all data, pretty much, starts life as an event. We think of databases, we think of state, we think of where I'm going to put it. That's implementation. We're summarizing up events. But events are at the heart of most things that happen. And events are these fascinating things because they comprise two properties. They're a notification that something happened, and they're also a transfer of state. So it's not just an order was placed, go and look up information about that order. It's not just, here is information about an order. Well, are there any more? I don't know, I'll just kind of have to poll it again. Events give us both. An order was placed, and here is that order. And so events are all around us. Events are generated by our customers, they're placing orders, they're phoning our call centers, they're clicking on our website. Events are also generated by machines. We have sensors generating events, we have our mobile phones generating events, we have our applications generating events. Events are this very, very broad term that encompass a lot of things, but it's something happened. Whether you're talking about a user clicking on your website, whether you're talking about a transaction happening in a bank and transferring some money, whether you're talking about an application logging a message. This happened, and then this happened, and then this happened, this was bad, this was good, whatever. Applications logging messages are also events being generated. Databases are also a source of events. And this sometimes makes people scratch their heads a little bit. But databases is a source of events, and understanding that actually gives you a good head start in understanding how you can migrate from your existing view of the world to an event-driven view of the world. So databases are a source of events because of this thing called the stream table duality. So the stream table duality explains how we can actually go between this idea of state and of a stream of events. So if you imagine a bank account, you've got a database table, and you go to the database table and you say, I would like to know what the balance is for my bank account. Bank account 12345, what is the balance? Select balance from table where key equals 12345. And it says the balance is 50 euros. That's your state. How did that get there? There was an event. The event was I deposited some money in that account. And then I deposited some more money. And now the state has changed. The state is now 75 euros because I deposited 50 and then I deposited 25 and then I spent some. So I spent 60 euros and now the balance is 15 euros. So you have a table on the right-hand side giving you state for a given key, and on the left-hand side you have a stream of events. That stream of events you can replay to build your state. You can also take the state, the table state, and every change capture that to give you a stream of events. It's a duality. They can go between the two. So you'll notice from that, all you actually need is the left-hand side. All you actually need is that series of events. From that series of events, you can rebuild your state. From your state alone, you don't know the series of events. You just know the current state. But from the series of events, you have both. So if you have a series of events, if you know how the withdrawals are made, the deposits are made, you can actually rebuild that state. So there's this great quotation from Pat Helland: the truth is the log. The database is a cache of a subset of the log. If you've got an immutable log of every event, you can rebuild that, you can materialize that to give you your state, which is very, very powerful. Because at the heart of what we're working with are events. So the example I gave you then was events in the form of withdrawals, deposits on a bank account. Let's think of a different set of events. How about we've got an online grocery store, and that online grocery store has got a basket. I did some shopping for my tea tonight. I'm going to have tin spaghetti on toast. So I buy some bread, and I buy some tin spaghetti. That's the state of my basket. How did I build that basket? I don't know from that state. The state only tells me the state. The events are interesting, because I put some bread in the basket, you need bread to make toast, and then I put some baked beans in. And then I changed my mind. It's like, actually, no, today's Wednesday. Today I'm going to have tin spaghetti instead of baked beans. So I take the baked beans out of the basket and I put in tin spaghetti. Silly example, I know. But the point is, you have behavior that is captured in those events that the state alone doesn't give you. If I have the state alone, all I know is that a customer bought two things. Did they change their mind when they were building that basket? What caused them to change their mind? Was there an advert for tin spaghetti shown at the same time? And it's like, actually, that advert has had a significant impact. There's business value in that because they changed what they were doing. There is behavior captured in those events, which if all we do is work with state, we lose. Whereas if we capture the events, we can rebuild that state at any point in time. So what we need is a way of capturing events in an immutable, append-only way, ideally which is kind of distributed and scalable, because we can then rebuild our state when we need to. So we have this stream of events. We're going to capture it on something called Kafka. So Kafka is an event streaming platform. Hands up who knew that. Hands up who thought that Kafka was just like this pub/sub message bus. So, I've got Rabbit, I've got Active, I can use Kafka. It's just that. Quite a lot of people do think that, and you wouldn't be, it's understandable why people do. Because Kafka kind of started life as this kind of pub/sub thing, but it has grown to be a lot more. Kafka is this event streaming platform, and if you came to my talk earlier, you'll understand why. You can actually build full applications on top of it. So Kafka, at its very, very heart, is this immutable, distributed commit log. So every single event is produced onto Kafka, and it's appended to the end of the log. So I'll put up some links at the end. There's a book called I Heart Logs by Jay Krebs, who's one of the people who wrote the original Apache Kafka. There's also an article he wrote, what every software engineer should know about the log, because the log is a fantastic fundamental concept that we don't really think about. There's not kind of like a parallel in a lot of things that we're used to in our kind of first technologies that we reach for. Databases are actually built on logs as well, but we don't realize that. We work with kind of like the top end, the SQL type stuff. But the log is a fantastic abstraction on which to build. So Kafka gives us that. It gives us this immutable, append-only commit log. Within Kafka, you have topics. So topics, kind of like database tables, it's a way you can like model your data and split out your entities. And the data in Kafka is persisted. So when you consume a message from Kafka, which I'll talk about in a moment, it's not deleted from Kafka. Messages are only deleted from Kafka when they're aged out based on time or based on the size of a particular topic. There's also something called log compaction, where you keep every key in a topic, to keep the latest value forever. So it's up to you as the user of Kafka how long you persist your data for. Within your topics, you can partition them. So you can have one partition and you can only ever consume sequentially, serially. But you can also partition your topics and start working with the data in parallel. So partitions are your unit of scale. So Kafka is a distributed system. You can run your consumers in parallel and consume the data in parallel. The data that's on a topic, it's just key value bytes with like headers and timestamps and stuff. But the actual data that you're putting onto Kafka, it's up to you as a developer how you serialize that data. So Kafka is this log with bits and pieces on top of it, like various APIs on top of it. If you think kind of like the other end of where we're at, you've got kind of like relational databases, which have got like 40 or 50 years worth of development on them. And you just simply have like, it's SQL. Create a table, it's got like this data type, I just do an insert, there's my data. Kafka says, well, here's your log, and we're going to start building capabilities on top of it. We've got a producer API, we've got a consumer API, we've got a stream processing API, we've got an integration API, but there are some things that you as developers need to care about, and one of them is how you serialize your data. So there are good ways, and there are really bad ways. So if in doubt, this end, not that end. So using something like Avro, using something like Protobuf gives you very strong support for your schemas in your data. Schemas matter almost always. So it's very, very important that you think this through. Sometimes people make the mistake of reaching for what's easy, which a lot of the time is JSON. Oh, yeah, we use JSON for lots of things. Everyone's familiar with JSON. I'm writing this thing to get data from here to there. I'll use JSON. But you're not. You're writing data that's going to be produced by you, an event happened, and then someone else says, yeah, I'd like to know about that event, so I'll read it from there, which is fine. But then someone else comes along and says, well, I'd also like to know about that. Those clicks on the website, those orders being placed, those readings from the sensors, I also want to know, and I also want to know, and I also want to know. And now you suddenly have 4 or 5 people all saying, I want to consume that same topic. What's this JSON again? Which fields are expected? What's the data type? If only we declared a schema. So it's one of those mistakes that people make with Kafka when they first do it, and then they end up having to roll back and kind of think, oh yeah, we probably should have gone this way. And people do, because it is that important. People will actually pause their projects, say, right, we're going to have to step back, we're going to have to reintroduce, use something like Avro instead, and then carry on. So learn from mistakes, use something like Avro first time round, and you'll be glad. So the data on Kafka, you can read from the topics, and all of the consumers are independent. So like I said, when a message is read from Kafka, it is not deleted. It's simply the position of the consumer is kept track of. So here's our log, here's all our events that have been added to it, the old ones, the new ones. Here's Sally, she comes along and says to Kafka, please can I have the messages? Kafka says, well, this is where you got to last time, so I'll play you all of those new messages. Someone else comes along, Fred hasn't connected for a while, Fred says, oh, I've got all of these ones to go through. George comes along, can I read these ones? Oh, actually, I made a mistake in my processing, or my application crashed, or I want to reprocess them. George can say to Kafka, actually, give me all the records, or since Tuesday, or since offset 43. So consumers can scan through the log to any particular offset, And Kafka keeps track of where each consumer has read from. Your consumers, you can also group together to parallelize. So you have something called consumer groups. So one logical application could have multiple physical consumers consuming the data in parallel. So Fred here could actually have kind of like Fred 1 through Fred 10 and read 10 partitions in parallel. So Apache Kafka, it's a log at its heart. There's a producer API, there's a consumer API in Java, C, Python, .NET, kind of like all sorts of languages. But there's also other APIs which is really important to be aware of. You've got the connect API, which is basically for doing streaming integration. So you want to get data in from systems into Kafka. You've got data that you want to get from Kafka out to other places. You can use Kafka Connect, and it's just a configuration file. You don't have to write any code around it. So if you want to, you could go and write some Java code, kind of like pull data in from here, and kind of like, why don't we build a framework that's going to be like scalable and fault tolerant and handle schemas and offsets? It's like, well, congratulations, you built Kafka Connect, because that's what it does. So people like solving problems, but solve different problems. Kafka Connect has solved the problem of getting data from source systems into Kafka, from Kafka out to target systems. There's also a stream processing API. So you can write applications that are going to process your data as it flows through Kafka, or indeed data that exists in a Kafka topic that you want to process. So you can use Kafka Streams API to process the data. You can also use KSQL. So depending on your preference for languages or whatever you're adapting internally, if you're using Java, you've got Kafka Streams. If you're not using Java, if you're using .NET or Python or whatever, or if indeed you don't want to write any real code, you can write SQL and use KSQL. So that's a stream processing application there, as is that. That's obviously got a bunch of stuff around it to make it actually run. That actually is how it runs. That's the code that you pass to the KSQL server. So all of this is kind of different from what we know before. This is not just kind of the latest database 2019 release 42. That's kind of like the previous one with a few different bells and whistles, and now this one kind of like does this and it does that. Kafka lets you build things in a different way. If you try to pigeonhole Kafka in your mind into kind of like, well, it's just like a message queue, or it's just like an integration tool, or it's just like a database, which funnily enough it kind of is, then you end up misunderstanding how it should be architected and kind of getting into the problems where either it doesn't work, or you think, well, this thing's a piece of crap because it's not fitting how I want it to. But that's the classic problem of like, here's a square hole and let's bang a round peg into it. Kafka is fundamentally different because it's built around events. So I want to give you an example of the kind of thing that you can build using an event streaming platform and thinking about the role that Kafka plays in it. So let's say we've got a website. Maybe it's the same website where I bought my tea from, and you can leave reviews against the different products. So the website, it's using the producer API, it's sending messages to a Kafka topic every time someone leaves a review. And the first thing that we want to do is we want to be able to build a dashboard for our operations team to put in front of them to say, here are all of the reviews that are coming in. So it's like it's a good review, it's a bad review, whatever. So we produce the data into Kafka, producer API, into a topic called reviews. And we use Kafka Connect, we stream it down to Elasticsearch, we put Kibana on top, happy days. Requirements solved. But then someone says, well, actually, we want to start analyzing that data. We want to put it into our data lake. Our data science people are going to do fantastic data science things. So actually, we can now take that same data and we can stream it from Kafka down to, or up to, our data lake. So by using Kafka, we avoid the problem of we've got data coming in and we've got someone who wants to report on it. What's our usual way of solving that? Well, here's the data, here's where we're reporting on it from, we'll pull it in from there. So we've got like a nice, direct, tight coupling between them. Because by using Kafka, we solve that first requirement, but now when the new requirement comes along, we simply hook up the new thing to that existing source of data. We're not having to go back to the original source. We're not having to hook up to the operational dashboard and do nasty things like that. We're not having to say to the source system, please can you now also write it to this new place. An event happens, we write it to Kafka. Anyone who wants to use that event can then access that topic with the appropriate security and then use that data. But we can also start to cleanse that data. We can say, well, let's take that stream of information and let's filter out the bad records. So we can use something like KSQL to read from the source of data, apply a filter to it, and write it back into Kafka. And now we've got a new Kafka topic that, again, applications can benefit from. We could say, well, in our operational dashboard, they need to implement that logic. And in the data lake, they need to implement that logic. Data science team, when you're doing your data science stuff, by the way, filter out nulls. Operational dashboard, by the way, make sure you include a filter for nulls, because otherwise you get crap results. Or you could say, as the data comes in, as the system owner, as the kind of like whoever that responsibility falls to, I'm going to write an application, simple stream processing application. It's going to cleanse that data, write it back into Kafka, and now anyone who wants the clean set of data can read it. A lot of the time, we want to enrich data as well. So far we've talked about getting a single set of data coming in and passing it through to this place and that place. But something like review information, we want to know, well, who was the person who left that review? Were they an important customer? Were they like platinum status? We want to make sure if they leave a bad review, we can kind of like do something about it straight away. What's their email address? What's their phone number? And the kind of places where we keep that information is usually a database. So the reference information, it's going to sit on a database over here, over there. You can pull databases into Kafka because of this stream table duality. You can say, I'm going to take a snapshot of this table and copy it into a Kafka topic, and then every single event that happens to that table, I'm also going to stream it into a Kafka topic. And then you can say, well, I'm going to join that information. I've got my review information here, I've got my user information there, both in Kafka topics, but on the basis that I'm assuming these people and those people and anyone else will probably want to know who was the user who left that review. Why don't we do this transformation once and make that data available also within Kafka? So again, stream processing application, here we're going to use KSQL, create this stream, enrich reviews, select everything from the reviews in a join to users on the user ID equals user ID. So now we have another topic within Kafka, but which is enriched with information about the users. Now, we want to say, well, actually, I'd also like to be able to notify people if someone leaves a bad review and they're a super important customer. So each of these individual things are very plausible, very common requirements. An event happens in the business. Someone places an order, someone leaves a review, someone phones the call center, a customer does something. We want to know about it straight away in our operational dashboard, what's like the current pulse in the business. We want to analyze it long term, we want to train machine learning algorithms on it, we need a kind of like data lake type area. But we also want to drive applications on it. We want to trigger an alert. We want to trigger a system process that's going to go and do something because an order was processed. We want to do something based on that event. So in this case, we're going to say, if it's a super important customer and they leave a negative review, well, we need to respond to that straight away. We could, I guess, have something in the data lake. We could run like a weekly report, like select star from here, where a user is not happy and they're important, and like on a Monday morning, we could print something out for someone to go through on their desk and phone up the customer and say, I'm really sorry. But that doesn't really cut the mustard these days. These days, we've got infinite different websites to choose from. If this one sucks and annoys us, we just go to that one. Next week, someone phones us up, it's like, yeah, well, that's fine, I found a different supplier now. So if we can actually do something as soon as someone leaves a bad review, then we can actually hopefully retain that customer. So we can create another stream of data, create stream on happy VIPs, select everything from the reviews where the rating's less than 3, and the customer status is platinum. So we write that out to a new topic, and then we hook up a service, and all that service has to do is say, subscribe to this topic. Oh, I've got a message. Fine, I'll send a notification. I'll phone the customer, I'll text them, I'll pass it to a customer phone person. They can contact them, but it's straight away, it's driven by the events. But each of these things is nicely loosely coupled from the original production of the events. If you want to consume the raw events, you can. But if you want to benefit from the cleansed data, from the enriched data, you also can. So I want to talk about some of the patterns that were within that. Because I'm imagining most people aren't going to go back to the office tomorrow and go and build that. Probably. Most of the time, it starts off as, I've heard about this thing called Kafka. I think it could probably help us out here in this particular case, or where we've had this particular problem in the past with a bit of foresight. Maybe it's going to be appropriate to put Kafka in here. Maybe it's not. Whatever you do, don't use Kafka just because it's cool. That's a really crappy reason. It's good for your CV, but it's a crappy reason for actually implementing it. Use Kafka where it fits and is appropriate. But Kafka is one of those things that it gives the architectural underpinnings to actually succeed over various iterations of your system. It's not about, I've got this requirement today, is this better or that better? It's about the system's going to evolve. Systems always evolve. Like that picture at the beginning of the jungle growing up and things like that, things always evolve. There's always new requirements, there's always new teams, new products. Kafka gives you the underpinnings with which to evolve what you're doing by more loosely coupling things and making the data available in a source-agnostic way. So, not everything is a nail. You don't always just want to use like your stock relational database for doing everything. Relational databases are great. They've evolved an awful lot over the years, and they can do a lot of things very, very well, and many more things quite well. Is it always the most appropriate tool to use? No. Is it the appropriate tool to use sometimes? Definitely. But choosing the most appropriate tool is important, and Kafka gives you that ability to do so. You don't have to tightly couple, I've got something happened, I'm going to write it to the database. I've got some state, I'll write it to a database, because now you're coupling everything else to your database. Instead, if you write it to Kafka, you can also have it sent to the database. But you can also send it to Elasticsearch. You can also send it to your graph database and do your search indexing and your property graph analysis using the most appropriate tool. You can also, for your particular thing that you're wanting to do, you can also evaluate different technologies side by side. You want to do some kind of big data analytics work. You say, well, we'll try out HDFS alongside BigQuery, alongside Snowflake. They all do roughly the same kind of things. But trying it out with kind of like static lumps of data, it becomes difficult to actually do like-for-like comparisons. Well, we loaded this from here from production, and then we loaded this, and then that changed, and then this changed, and you don't get a proper feel for what it's like to actually do these things side by side. Do they perform the same? What do they like to operate? Kafka gives you the ability to say, well, the data comes in, and actually we'll try it against all three. What are the pros and cons of each? And when you've settled on one, we can just turn off the others, because you've now got that live stream of data already set up and flowing in. You can do the same thing at the other side. You can say, well, I've got this current source of data, and it's currently writing to these two different applications. I could say, well, my producer, it's on premises, it's going to send data directly to this application, directly to that application. That's okay. That kind of satisfies the initial requirements, but things change. So then next week, next month, someone comes along and says, well, actually, we've got a new version of the application. We're going to migrate it into the cloud. Or we've acquired a third party. They've got the same data, but they're based in the cloud. So now we need to get that same data to those two different applications. So now you start like hardwiring these things together, and this to that, and this to that. Or you could say, well, we've got the same data, so each is going to produce it into the same topic. A, B, C, Z, they all consume it from the same topic. And then we say, actually, turns out we can turn off that on-premises application. Those applications just carry on happily as they were. They subscribe to the topic with the events they're interested in. Where those events are coming from doesn't matter. The producers, where those events are going to, doesn't matter. They just send it down to Kafka. So this tight coupling is not flexible. It's what people reach for instinctively. I need to write some data for my application. I need to write it to a database. I need a database. That's what we've always used over the years. I need a database. But it's not always the most appropriate way to do things. Because you start off writing it to a database, and then someone says, well, we need that same data. We need to do some analytics on it. So can we do a scoop extract from our database into HDFS? And then someone says, well, the work that you've done on HDFS, like you've enriched the data, and that's quite interesting, and we'd like to use that data to drive a new application. So can you take that data from HDFS and put it into Kafka so that we can drive our application using those events? And this is the kind of thing that people do come up against. I wish I was making that up, but that is based on not just one example from Stack Overflow, from Slack, from the community, where people have this kind of system. because it's evolved bit by bit. First, the database. OK, we've got a database. Oh, now Hadoop. OK, we'll just add on that. And then we'll just add on that. And then we add on this. And suddenly, you're at that point. If instead you say, OK, we're producing data. Something happened in my business. We're going to send it to Kafka. We also need it in a database. That's fine. We also need it in Hadoop. That's fine. We also need it in our new application. That is also fine. Turns out we don't need Hadoop anymore. That's fine. We can turn it off. If you do it the other way, you want to turn off one of those pieces, you're screwed because you need to rewrite the rest of it. So a more loosely coupling thing gives you this freedom to evolve. It means that you're not boxed in to your initial decisions up front. You can actually go with as things change. We can also transform once, use many. We can do data cleansing, we can do data enrichment, we can do joins between reference information. We could say we've got information coming in from like millions of different IoT devices. And we're sending it's temperature readings. We've got different applications using that data from the raw feed of data. There's a problem with the raw feed. Some of the sensors are broken. They don't send through a sensor ID. Option one, we say, well, let's cleanse the data at the application. Kafka, it's just a dumb message bus. Like, that's all it's doing. It's just passing the messages through. My assumption is I'll have to process the data at the application. I've got 3 different applications, I've got 30 different applications. Each one implements their own cleansing logic, and we hope that that one bug just stays the same, because otherwise we have to tell 30 people to change it, and that's never going to happen. Or we say, well, that's fine. Whichever team's responsible for that data coming in, or whoever, they can write a stream processing application. They can cleanse the data, write it back onto Kafka, and now our applications can say, well, that's fine. Now I can consume from this cleansed topic. Or not. They can consume the raw data as well if they want. I don't want to give you this impression that we're just kind of like replacing like an ESB way of doing things. I need to cleanse the data. I have to go to my central team who will do some data cleansing, and I have to wait 6 months for it to happen. It's not that idea. Anyone can work with the data. Anyone can cleanse the data and write it back onto Kafka for other people to benefit from. So, last example, we have systems producing the same data but in different formats. So you've got an existing on-premises system, you acquire another company, they're also writing orders, but they use a different format. They've got a different envelope around it, they use different field names. Kafka and processing the data within Kafka is a great way to manage that, for kind of like integrating different systems. You've got the original producer, it's producing squares. Your consuming application is expecting squares. The new one comes along and says, well, I've got triangles, squares are old-fashioned. You can write a stream processing thing which says, well, that's fine. I'll unify those schemas, I'll transform it appropriately, and then the consuming application, it just carries on consuming from that topic, except it gets new data. I'd love to rant some more about schemas, but I'm out of time. At the heart of all of this, I would urge you to think about events, because they model what's happening in our businesses, whether customer-generated, people-generated, or machine-generated, and also think about the systems that you're building and make them flexible and that they can evolve over time. Don't let yourself do this kind of thing, which is the mistake that people have always made over the years, for understandable reasons. It's always this to this, this to this, this to this, oh crap. If you build around an event streaming platform and using events as the basis of it, you can build something much more loosely coupled and scalable and powerful. So events model the real world. If you're just capturing state, if you're just passing messages around, you have this kind of like mismatch between what you're trying to do, which then shows itself through the architectures that you build. If you're using an event streaming platform, you can do your native stream processing, you get the data where and when you need it, you can persist your data, and it gives you the flexibility and scalability as well. If you want to go and try it out, Confluent Cloud is a managed Kafka as a service, the schema registry with KSQL, and so on. These are the books that I mentioned earlier. There's the I Love Logs, the definitive guides, event stream-driven systems. They're all very, very good books. You can download them for free off our website. You can go and scan the QR code there. I'll tweet the slides. I'll tweet the link to that as well afterwards. So with that, thank you very much.